Hello again. So today I have a mission to try to land on the moon. I was kind of started doing it off screen, but realized there was a bunch of interesting things I wanted to discuss during it. Let's see, I've got set myself to my regular low inclination relative to the moon. I've shown how to do that in a number of past videos. So this is a whole different kind of rocket design. The first stage is powered by a cluster of 6 NK9s, which is an engine I believe were designed but never flown. Kind of an early version of the NK-15, 30 or 33. Basically engines that were leading up to the N1 rocket that the Soviets definitely did launch off the ground a few times, but never, I don't think any of them actually even made it to the second stage, which is really a shame because they were the same scale as the Saturn V. So those were massive launch failures, unfortunately, for the Soviet Union, and they covered it up for a really long time. And even today you can only find a fairly limited number of pictures and videos of it. But anyway, this was an early design. They're trying to build bigger nozzle, so more thrust per individual nozzle. Engines, if you'd notice, this rocket is way more light than R7 rockets, but in part that's because these engines are also more efficient. Not a ton more efficient, but definitely enough. So it's this is specific impulses rising as we climb out of the atmosphere, and the upper stage. So this was started at below 260, 70, something like that. And the upper stage, the vacuum versions, get up to about 350. So they use a different type of engine cycle known as closed cycle. There's a couple different versions of that name, so keep it simple and won't try to be precise with it. But it means that the pre-burners, so some of the tools they use to spin up the pumps for the total fuel, those burn a little bit of fuel, and in this case they take the partially burned fuel to spin those pumps and then put it back into combustion, so it doesn't get wasted by being just partially burned. So those are pretty efficient engines. Approaching staging now. I'll try to do it. Come on, if it'll let me catch up. Just try to tip myself down a little bit there. Light the engine, of course. There we go. Okay, and how is the dynamic pressure? It's getting down there, so pretty soon I'll drop. So these are engines that were never flown, but they were designed, and therefore we have accurate enough values to put them into realism overhaul. So in my current mission, I'm trying to gain some prestige. Hopefully, trying to get a bump, just something to fill until I get like a Gemini or a two-person type capsule, so that I can complete that objective and move towards the station contract that I want to test out. I found all kinds of weird little glitches and bugs and things that I've kind of improved along with other people this playthrough, which is usually why I only do a playthrough of RP-0 once in a while, once very rarely, maybe once or twice a year. Just because whenever I play through it, I'll make it a lot further than I did the last time, because in this playthrough I will have improved so many things, just found weird bugs and fixed those bugs. Sorry, just to close something there. And yeah, just if you look at our GitHub, you'll see all kinds of issues and pull requests. Like, for instance, I wanted to send a probe to the surface of Venus, and so the Tantares mod includes the Venera lander craft for that, which is great, but it's not, it wasn't completely configured. Like a couple of really clever guys who were also playing these missions actually went and dug up the papers and found, no, the Venera lander definitely should be able to do this. Because apparently historically in crashing through Venus's atmosphere, it hit a maximum acceleration of 450 Gs, which just seems crazy. Usually fails like kind of the brain logic check, like should a part or craft be capable of doing that? No. Okay. But when somebody is awesome enough to dig up a paper so it shows, yes, that is actually what it did, then we oblige. We have to figure out, okay, how do we get set apart so it can do that? And so Nathan Kell thankfully knows all the tricks. He figured out the line was on a lowercase g tolerance in module arrow or something. Anyway, we figured out the code so that the Venera can now land on Venus at that initial, like the actual designed crazy acceleration or deceleration in the atmosphere it hits. Host all kinds of weird little things, like there's a couple of the Tantaris Voskhod, kind of the better version of the Vostok craft, which the Soviets used to launch the first individuals into orbit. And then the Voskhod did some pretty cool stunt missions that I don't want to recreate here. Let's see, am I heading down still? Yes. So that included the first time to put 2 people into orbit, the first time to put 3 people into orbit, and the first spacewalk. So the electronics at that time, if you're not quite aware of how quickly technology was developing during the space race. So at that time, both the Mercury, the Americans' first capsule, and the Vostok, the electronics produced a ton of heat, right? Just like an old-timey radio. It's like that. That's kind of the starting benchmark for their for the electronics they're working with, and they produce so much heat that you need, just like your computer, you need fans, you need a gas to absorb the heat from the equipment, so it doesn't overheat. So in an EVA, when you want to send a person out of the capsule, you drain the capsule of air, and if there's no air, your electronics will overheat and fail. So that is why, that is one of the reasons why in the Mercury program they did not use that craft to perform an EVA. The Soviets, though, they wanted to. They were big on stunt missions, so they wanted to do world firsts. Right, every time we send something up and where we've invested the resources to make it successful, we don't want it to just be successful. We want it to be the greatest thing that's ever happened in some field. So first human into orbit, first object into orbit, first human into orbit, first group of 2 or 3 astronauts into orbit, first female astronaut into orbit, first rendezvous where 2 craft, I think they got the first rendezvous, but I could be wrong, where 2 craft were launched and they were in the vicinity of each other. That generally implies a great deal of control of your craft, whereas they did it with a great deal of control of exactly when they launched, which is impressive, but not as impressive, in my opinion, as the control demonstrated by the Gemini craft. But anyway, I get ahead of myself. So there are a number of interesting parts in the Tantaris mod that still need a bit of tweaking, both to get the price and weight and exact positioning in the tech tree and stuff figured out. So I've just made myself some notes of those things, and kind of want to get some of those more polished and figured out, so that next person who plays RP-0 is able to use those parts without just giving up on it in frustration because that part's not configured, or having to go the slow route like I'm having to, and and configure it themselves. But thankfully, I have a lot of experience in running into bugs or problems in RSS or RO or RP-0, and kind of being able to figure out how to fix them, which is awesome. Because I do that, other people can fly these missions later on. Sorry, it's a bit late here. And this is the 3rd time I've tried to launch this mission, so let me figure this out. So I had this tank locked because I didn't want it to count against my delta V when I was designing it. So now I'm going to I want to do the Hoffman or Hohmann transfer to the moon. So set target, create node, and it's going to shoot me at the moon. So I'm going to line that up, and I'm going to carry it out, and I think that will be it for this video, just kind of setting everything up, because this will be my first, hopefully, a lander on the moon. It doesn't even have legs. It's just a really dainty little craft. Like even just in Earth orbit here, I've only got 4.5 tons, which isn't that much payload at all. But if it's sufficient to hopefully place the first craft on the moon, that will be handy. So there's a couple of parts that I've seen in place here that represent the Russians' first hardware that they soft landed on the moon, which is a really crazy design. And Raider Nick has an excellent implementation of that I'd kind of wish was in realism in RP-0. It has configs for Realism Overhaul. Just it's, like many of his mods, they're memory hungry, and I'm basically at the limits of my memory, of my RAM here. So those are basically, I'll be doing missions with like every Raider Nick thing in once 1.1 comes out. Okay, so it looks like it's 51 minutes until it comes back around where we can do that launch. So okay, so I'll just give myself a quick save here and tell it to execute node. So now I'll try to do it exactly the way that I did the first time when it was successful, and then I decided that I wanted to record it. So I've sent up fuels. Notice that none of these except the electricity are declining. And that is because all of these fuels are called hypergolics. So they're high enough energy, crazy chemicals that they can be used for, as rocket fuels, but they are not unstable thermally, like they're not cryogenics, which is very useful. So here I had to turn on the RCS. So I hit space to turn on the engine, and then I'm hitting H to, there we go, to thrust forward, because hopefully before the time the mech-jeb kicks in and tries to light the engine, I want it to already be active, so I staged it even though it was down thrust. That's an important thing I wanted to show in this video, because in the past I've been a little confused. I wasn't sure exactly what the most effective route to do that was and why, and there we go, I found it. So get everything into position, and then when it's kind of getting ready to go, space to stage the engine so it's active and available, but is it's not throttled up, so it's not going to consume any ignitions, and then use your RCS to ullage it so that it reports very stable propellant, and so now it is on. So the fuels it's burning are stable under a wide range of temperatures. They're not like liquid oxygen or liquid hydrogen. As if there's not a ton of chemicals that are like that. They're really quite a fascinating set. There's a book called Ignition, I believe, which is a really fun book written in the 50s, I believe, or written mostly about events that occurred in the 40s and 50s, as told by a chemical engineer or a rocket fuels engineer who actually invented one of the best RCS chemicals and propellants in the game, in my opinion, which is Cavia. Cavia A or B, if I recall correctly, because of course it's never as simple as they hope it is on the drawing board or in the chemistry, and they find, okay, we made one version, it has some properties that aren't ideal, like let's say it'll freeze at a certain temperature, it's not quite as stable as we want, so then they reformulate it or mix it with something else, so they went from Cavia A to Cavia B. It's a really fascinating read about the development of these complex chemicals that are shortened here to things like Aerosine 50, which I think was Aerodyne, or some space company with Aero in their name decided their brand would have their name in it. That's also discussed in the book. And NTO is nitrogen tetroxide, I believe. Aerosine 50 is very similar to hydrazine, if I recall correctly. It's like half hydrazine, half something else, maybe half UDMH or something, which is unsymmetric methyl hydra. If you're familiar with chemistry, I'm sure it sounds like I was about to say something smart, and then I choked on it. I don't know my chemistry terms all that well. Like complex chemistry. I don't even know if in this case we're talking about organic or inorganic chemistry. I think a lot of these things are organic, because they contain nitrogen and carbon, oxygen, and whatnot. And so you can see a couple of bodies here. So some of what I've left behind is getting left really far behind now, 80 kilometers. And, Jupiter on one side of the sun and Venus on the other. So I'm just going to let it jump forward a bit. So the efficiency of this fuel isn't huge. Like while I was coming up, when I was doing my initial launch, I had a specific impulsor efficiency of 350 seconds, and it's just a bit of a trade-off, because that's kerosene and liquid oxygen, where if I carried liquid oxygen into orbit like this, I'd have to be far more mindful of when exactly am I using it, because it's going to be boiling gradually, unless I also thought ahead and have tanks that can keep it from boiling. But I don't even believe I have that technology yet, and at the time of the Saturn V use and Apollo landing, they didn't either. they were very constricted. Even though they're hauling this huge rocket, very capable, into orbit for a brief period, it could have only cycled around the Earth. It's about 90 minutes for an orbit. It could have only have done that once, twice, 3 times, very few times, because every time they went around, they would be losing more liquid hydrogen, a bit of liquid oxygen, and the more of that just evaporates off into space, of course, the less you can use as fuel. So at some point, you're just not going to have enough fuel to send your capsule out to the moon. So it's the interesting trade-off of rocket fuels. So there we go. So we've completed our burn off towards the moon, and I'm going to shut down avionics, lock these batteries, because it's going to be a 3-day coast out to the moon. And in the meantime, I will, let's see, focus view. So we got close to the moon. So I'm going to attempt what's called a direct descent. Rather than, like, say, getting close to the moon like this, and then at this point, no, don't warp there. Rather than add a maneuver, rather than getting to a point like this where you're behind the moon, and then burning to slow yourself into orbit, and then other like gradual things, I'm going to change my course so that it is, see if I can bump it around a little bit, where it's more like this, where it actually, I'm going to hit the moon, and then I'm going to use a tool like this that accounts for the fact that the moon rotates. So somewhere, there we go, so you can see that where that orange line hits the moon, so assuming light doesn't change too much before then, I'll be just on the night side, which I don't want, and the moon will have rotated so that it's this chunk of moon that I'm landing on, which I also don't want. So I want to fine-tune those because I want to land somewhere on the daytime side, and ideally I want to time things so that I hit a much more smooth part of the moon. But beggars can't be choosers. It's not like this craft is going to return, so really anywhere I smash into the moon, as long as hopefully there's some sunlight, will be good enough for me. But I'm going to do a little bit of tweaking of that, and that will really just be through, like right now is just hitting the 6 keys to translate around or move around. I'll basically set something mid-course and fiddle with that. So thanks for watching that ascent, and next video will be, hopefully I will have fine-tuned that to a nicer spot to smash into the moon on, and I will use my remaining delta V, which is more than it is showing here. I did lock this tank. That's going to be most really, if I get into orbit of the moon, that's enough to land, I think. But I didn't look into it too deeply because I'm just kind of curious. I'm just kind of curious how I could do it. I've never tried to land with a craft with no legs like this, but I've seen a few other people do it. Looks neat as like a first thing to throw onto the moon. So that's how I'm going to do it. So see you guys again later. Thanks for watching.